Hey, top realized math industry, and we are gonna take a look at the force. So what we're gonna do is this is a physics video, and we're gonna analyze what the force even means. May the force be with you. And don't forget that today and tomorrow is basically Halloween. So happy Halloween. Type in the comments below what your costume was, or is, and let's see if there's any Star Wars related costumes that use the Force. So may the Force be with you. So when we think about force, we usually think about pushing or pulling an object. And yeah, that is correct. So that is one example. So a force is some kind of push or pull on an object. But we need to kind of dig deeper on that. But also, we need to kind of analyze, like, how does the object move? And, like, what are the properties and, like, how it can move? That's why it's a physics-related thing. So, what are the fundamentals to know what the force is? We have to look at the 3 laws that Newton had figured out when he understood how objects interact with the world and with each other. And these 3 are simplified so they can be understood and also you can have fun with it. So here's what happens. Newton's first law is going to come first. And it kind of creates the fundamentals of like, hey, what just happened? An object in motion will stay in motion and an object at rest will stay at rest. Unless acted upon some kind of other force. So it kind of makes sense that that robot is not moving and it's at rest and it will stay at rest. And an object in motion will stay in motion. However, this will stop because it will be acted upon another force. So if you're moving a car, if I move this Sharpie and I drag it like this, it's supposed to go on forever, but the reason why it stops is A, a gravitational pull is on it, but B, not only that, the so-called moving marker is hitting the ground, creating some kind of friction. So that's why it's gonna stop and go back at rest when it's acted upon some kind of other force. The next thing we're gonna take a look at is what the formula is for force. The second law that Newton had figured out. Isaac Newton. Force is proportional to an object's mass and its acceleration. So when an object goes somewhere or when it moves around, it creates an acceleration or some kind of momentum. And when it hits something, it creates a force. Maybe a force enough to bust open a door, like FBI, open up. So they have to back up and charge at the door to break it open. So the formula is force is proportional to an object's mass and acceleration. So here's what happens. Force denoted as the capital letter F, is going to equal your mass, multiply that by your acceleration. So if we can calculate an object's acceleration and how much mass it has, then we can understand how much mass per kilogram is acting upon an object, upon something, or yeah, pretty much anything. There are actually two more formulas that are related to this one, the formula for force. So if you ever wanted to figure it out, we can also calculate the force, the net force, is going to equal your mass times acceleration. But hang on, what is the net force? Well, we've been only analyzing one kind of force, but because we analyzed that marker that had stopped over there because there's friction, but also there is gravity, there is a net force. And when you think of the word net, I think of the network, like the internet, like your Wi-Fi so-called network. So here's what happens. Here comes your net force. Net force. Several factors that can act upon an object in different directions. So gravity is going to pull the marker down. Friction is going to stop the marker by friction by slowing it down. And the force that I push my finger with is going to slow down. So that's what net force is. And net force also produces and makes the acceleration part of the system. So when I move the marker, there's going to be an acceleration, but it will eventually stop because there's other net forces, or I would say a group of net forces acting upon it too. Oh, the other formula that we can take a look at is this. Your formula, or your force of G, is going to equal your M of G. Force right here and mass right here. But hang on, what is G? Well, here's what happens. So, no matter what happens, everything on here makes some kind of force on Earth. A, I'm sitting on the floor, so I'm making a force on the table. I mean the floor. B, even though that lotion bottle on that dresser is not moving, or it's not kind of making an acceleration, it's making some kind of force on the dresser right over there. That lotion bottle is going to push on the dresser because of a gravitational pull. Remember, a gravitational pull for your acceleration is going to be negative 9.8 meters per second squared. So if you drop something in an empty space vacuum without any air resistance, then it's going to fall at negative 9.8 meters per second squared. And not only that, when something falls, but also when there's gravitational pulls on Earth, that thing is going to create your weight. And that's why your weight is going to make some kind of force. And that's why there's a gravitational force. That's what the third version of this formula is. So we understand Newton's second law, but we still have to do one more law. And sure enough, it's the third. Newton's third law. Every action has an equal and opposite reaction. So, unlike many physicians or people that love physics, they love to joke around with the idea of what goes up and what comes down. Like, for example, what goes up, what goes up? Yeah. So, in this law right here, Newton's third law, anything that moves or has some kind of reaction, or actually action, it'll have an opposite reaction. If you're walking on the floor, not only are you using a lot of force to make yourself push forward, but you're using the force to push yourself forward, but also there's force going away from you, because that's how you get your traction. Just like a car, too. If a rocket is blasting off into the sky, it has to propel itself by having a really strong force. Force greater than the force it needs. but also if you calculate the amount of force that the thrust and the fiery stuff is acting on the launch pad, it will have the same force as the rocket is pushing itself. So yeah, we have learned about Newton's 3 laws of motion. So what we're gonna do is in the next video, we're gonna learn about the problems in the so-called force, and also we're gonna solve the math problems according to it. This is just part A. There will be 2 or 3 parts to this series. And may the force be with you. I hope this video has helped you understand the force. Thank you for watching Top Opinion Life's Math Industry. Like and subscribe. And if you have a math test, may the force be with you. I mean, if you had a physics test. See ya!